Good morning, class. We are introducing the power subsystem today. So we'll go over some basic terms that are related to power that are important, some fundamental concepts, then requirements, and then some design considerations. All right, so I know this is really basic and you should have covered this um, in your physics classes, but let's just review some fundamental like terms that we'll use when it comes to the power subsystem. So we are concerned with current, voltage, resistance, and power, and how that relates to charge and energy. So charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. There are two types of electric charge, positive and negative, commonly carried by protons and electrons. Like charges repel each other and unlike charges attract each other. An object with an absence of net charge is referred to as neutral. Charge is the fundamental property of forms of matter that exhibit electrostatic attraction or repulsion in the presence of other matter. We care about this because we're dealing with electricity in the power subsystem, so let's move on, let's power through. Current is the movement of that charge. So current is going to be the units of charge over a time unit. Electrical energy is a form of energy resulting from the flow of electric charge. Energy is the ability to do work or apply force to move an object. In the case of electrical energy, the force is electrical attraction or repulsion between charged particles. Electrical energy may be either potential energy or kinetic energy, but it's usually encountered as potential energy, which is energy stored due to the relative positions of charged particles or electric fields. Voltage, which is electric potential difference, is electric pressure or electric tension. It's the difference in electric potential between points, which in a static electric field is defined as the work needed per unit of charge to move a test charge between 2 points. Electric potential differences between points can be caused by electric charge, by electric current moving through magnetic fields, by time-varying magnetic fields, or some combination of these three. In electronics and electromagnetism, the electrical resistance of an object is a measure of its opposition to the flow of electric current. This reciprocal quantity is electrical conductance and is the ease with which an electric current passes. Electrical resistance shares some conceptual parallels with the notion of mechanical friction. The resistance of an object depends in large on the material it is made out of. Objects made of electrical insulators like rubber tend to have very high resistance and low conductivity, while objects made of electrical conductors like metals tend to have very low resistance and high conductivity. This relationship is quantified by resistivity or conductivity. The nature of a material is not the only factor in resistance and conductance, however. It also depends on the size and shape of an object because these properties are extensive rather than intensive. I have a diagram showing kind of an intuitive depiction of the three variables. So there's voltage, which is like the pusher. It's what kind of motivates the charge to move. Resistance is across the material and it prevents charge from moving to varying degrees, whether it's the material is a conductor or an insulator. And then current is just that movement of charge. Let's see, this picture here I have this is called a multimeter, or some people call it an ammeter, and it's measuring the voltage of a car battery. So that's how we measure the amount of charge in a battery. And we have algorithms that output the state of charge or the amount of charge in a battery. All right, so finally, electric power is transformed to other forms of energy when electric charges move through an electric potential difference, which is voltage. which occurs in electrical components and electric circuits. From the standpoint of electric power, components in an electric circuit can be divided into two categories. Okay, so these are the terms that we are interested in. Here is the mathematical relationship between these terms. So V is voltage, I is current, R is resistance, and here is just a common circuit diagram. There's something called Ohm's law, which is the relationship between voltage, current, and resistance, where voltage is the product between current and resistance. Using this triangular diagram, you can kind of isolate which variable you want and then the relationship between the other two variables to get your product. The relationship of power to all of these other variables, power is the work done per unit time. So it would be V voltage times times current, or it can be I can be replaced with current over time. And that final relationship I want to describe is the relationship of power to energy. Power is the derivative of energy, so you could find that as the difference in energy over the difference of time. Let's see, I want to go over units. Voltage, volts, current, amps, resistance, ohms, energy, joules, power, watts.